Thank you all for coming today. I need your help. I usually do a thing at the beginning of my talks to prove to my bosses that I went to a location and it actually did work. Didn't come to England just to watch soccer, although I did, and it was fantastic. I need you all to help me out. Can you smile and wave? And this room is so big, we're gonna do smile and wave there. Awesome. Thank you all. Put that away so we don't get distracted. If you are still here at KubeCon and you're in this room, you're gonna learn a little bit about testing, specifically end-to-end testing. And now I know each of you, like me, because we're software people, we're detail-oriented, you read the description fastidiously. You knew everything that I'm gonna talk about today. So of course, not only are we gonna talk about testing, we're also gonna talk a little bit about GitOps. Not a lot, but I do want to talk about the whole process, right? Where we take our code, we're going to build, test, and then deploy our application. And then we're going to talk about a few GitOps principles in there too that I wanted to share. So testing, why do we do it? We do it to evaluate and verify that our code is going to act as expected. Because honestly, two of the most important things in software development is that we make sure that our code works and that we can push changes out quickly. Because if our code does something unexpected, and if our users hit something unexpected, that's usually called a bug, right? And we don't want that. So with testing, we want to make sure we have our tests running, but we also have our tests automated so that we can push our changes out quickly and make sure that our software is running the latest things that the latest features that we want our customers to use. Our good friend Adler also said this about testing. It can work as documentation. I know for me, I've learned projects by getting into the tests first, running those, seeing how they operate, how it affects the code, even tweaking them a little bit to make sure that I understand what's happening. But then also, it can make for clear design and encourage productivity. We have confidence that our changes are not going to adversely affect our systems as we push them out. So end-to-end testing is that type of testing where we're going to be testing the entire flow. You have all different types of testing that you could be doing in your software development. You have unit testing where you're testing the most small objects possible, or even just the functionality on those objects. Then integration testing where we start snapping those things together. And end-to-end testing, we're going to be experiencing what the user experiences. So if you have a web application, a mobile application, we're going to be testing out that UI that's going to be interfacing with that back end, which is going to be interfacing with our data store. So we want the whole thing to be covered. And you might be sitting here thinking, yeah, Scott, that's a lot though. So if you think about it, these tests, you have to write them, that takes time. You have to think about how they're going to affect your system, or at least how you're going to take that flow. That takes time. How to set up a development or a test environment, that takes time. And it does. But like weightlifting, good tests make our applications stronger. Not only end-to-end testing, but we should also keep the other types of testing in mind. Whether unit testing and integration testing, we want to make sure each of those different aspects are being covered. The internet reminds us why. A real-world example, this lock was unit tested. It totally works. Or it doesn't. Who's written code like this? Me too. You wrote it to do one thing and then, oh wait, it's doing this thing. I didn't want it to do that. So you want to make sure that you have tests covering each of your situations. You also want to make sure that your test environment is as close to production as possible. I know in my career, there's been situations where my test environment may be running the latest and greatest, but my production environment is more stable. So you're not making a lot of changes to that one. You want to make sure that both of environments are the same, or at least as close as possible. Just like our little hero here, he sees that ramp and he's like, I got this. I'm going to hit that. We'll be fine. I can get through this course easy. When in reality, it looks more something like this. Our users have possible pitfalls, memory issues, maybe lag or latency, things that could come up in production that aren't coming up in test. So we want to keep our environments very, very similar. But isn't that the promise of containers? Isn't that why we have containers? We have application code and dependencies all wrapped into one nice little container. And then now I can take my container and share it with you on your system and share it with you on your system, and it should be the same. It should be running the same. But what about the configuration around that container and how that container is being run? Are they the same? Think about that. So I want to share a demo that I built on a subject that's near and dear to my heart. I love hamburgers. Who here loves hamburgers? And so do I. All the time, 8 days a week, I could have a hamburger, and they're fantastic. So I built this application to track all the hamburger joints that I go to and that I want to remember, but also to have my friends vote, see what they like, see if they like them too. And so I have this, and I wanted to show a picture of it because I want you to see when we're writing tests for this interface, okay, this is the interface that we're dealing with. Has a list of hamburger joints, has an add button, has some voting mechanism. So you can visualize that. Me, I'm a visual learner. I need to see this, I need to see diagrams, but also I want to see code. So I'm going to try to show all three of those to you today so that you can, each of those different types of learning, you can kind of see what's going on. And the hope is, as I'm sharing these ideas, sharing these tools, you can take them back to your team. The tools can be swapped out, right? I might show you a testing framework or other types of tools in this discussion or in this demo, and you say, yeah, well, I don't use that, but I like this other one better. And that's great. Hopefully, you can take the principles I'm talking about and still apply them to your team and make your tests a little bit better. So speaking of tools, for testing, I'm going to use Cypress. Cypress is an open source framework for JavaScript that allows you to write a JavaScript test inside of your, or for your application that tests your application. And so Cypress allows you to essentially assert things and check different aspects of your UI, find selectors in your DOM, manipulates them a little bit, and then sees if those changes are what you expect. In fact, let's look a little bit at our test code. We'll come out here to my project. And my application that I have, fairly straightforward. I have a back end, a front end, and my E2E directory. Each of these directories are going to be their own image, so they'll be their own containers inside of my application. And so my test code looks something like this. Come here to Cypress, E2E, and spec. There we go. In here, I set a couple of different values. First, I get a front-end URL. That front-end URL is going to test how Cypress is going to access my application because I want to test the entire flow, not just localhost on some port. I want to actually test the ingress that's happening. And then I'm going to have some data that I'm going to be passing in to my application. So I'm going to put a new burger joint in there. And then now I'm going to step through each of those tests. The first is testing to see if the page even loads, because if the page doesn't load, none of the rest of the tests are going to work, right? So you want to check that first, so that before each function is checking to see if the page even loads. And so we say we're visiting the Burger Place's site. Then we find an element on the screen, or on the page there, on the window. And we say, let's find this anchor tag that has an add on it. That's our add button. Then in the next test, I'm going to click on that add button because I'm assuming I found it. And so you step through your UI, you step through your process building on your flow as you go. So I'm going to click on it. Then after I click on it, it's going to open, I hope, it's going to open a form for me where I'm going to add my burger joint. And then I'm going to save it and then check my list. So this is what my test is going to do for my application. My application, as I mentioned, is going to contain 2 containers. They are running here in a cluster that's defined like so. I have a deployment for my backend that's going to refer to my backend image, my burger back image. It's going to be tagged with an image label that will be defined during our build process. Then I have a front end, very similarly, okay? And then I have ingress that's defined here at the bottom. There's lots of ingress providers out there. Today, I'm going to be using ngrok. And we'll discuss why as I get through my process here. So that's the code. And so our environment's going to look something like this. Again, I like to see code. I like to see diagrams. That way I can visually see how things work together. I'm trying to make my production and my test site as even as possible, as similar as possible. Both of them are running front-end and back-end pods. And then I have my test code container that's going to be interfacing with my test cluster. The flow, we're going to see that in a second. We're going to be using GitHub Actions as our platform for running our CI process, our process to essentially build, test, and then deploy our application. Inside of our GitHub action, we're going to be using K3s, super lightweight, nice Kubernetes distribution that allows you to spin up a Kubernetes cluster and then spin it down as you're running your GitHub action. And so our flow looks something like this. As a developer, I'm going to have an app code repo that's going to have my GitHub action in it, running my K3s cluster. That's also going to be the cluster or the area where I'm going to have my Cypress code running. And then I'm going to have my config repo. This touches on some of the GitOps principles I want to talk about. In this situation, the GitOps community recommends that you have your application code and your configuration code in two different places, in two different repositories, because both of them have different life cycles. You're going to be making changes at different times to your application code than you will be to your configuration code. Even different teams are going to probably have access to the two different repositories. And so in this demonstration, I wanted to separate them out just to show what that might look like. And so in this situation, we have our app repo, which is going to be checking out that configuration code during our GitHub action. It's going to be making some changes because it's going to be building our images and putting labels on them, right? So our configuration repository needs to know about those changes. So it'll be committing those changes back to our config repo. All right. So now, let's look at our GitHub action. And I'm going to be flying through this a little quickly. There's a lot going on in our GitHub action. Rest assured, I'll have a link at the end to show you how to get to all these resources, both the repositories, the GitHub action, all the resources I talk about. It'll be available at the end. So in my GitHub action here, I'm going to have it run on pull requests every time you open a pull request. Not only when you open a pull request, but also what they say when you synchronize a pull request. So in GitHub or in any Git repository that you'll be using, you open a pull request or a merge request, but then commonly you're going to be making commits to it after you open it. That's what synchronizing is doing. It's going to be running the test every time you make another commit on that pull request. It's going to be running out on any pull request that's trying to merge with main. And then we get into our dependencies. We're going to say that we want the GitHub action running on Ubuntu. We're going to check out the current repository's code, so the pull request is coming in. Here's where we're going to specify that we're using K3s. Then we're going to log into Docker so that when we deal with our images and push them around, and we want to push them up to Docker Hub, to a Docker registry remote from where we're working so that it can be deployed and run in production. So we log into Docker. And then here, we start building our Docker images. We're going to build our back end and our front end. We're going to tag them with the SHA of the commit. Another great practice to have. You always want to have your containers and your code commits to have the same identification. That way you can say, oh, wait, this particular image, this particular container is running with this particular revision of code. Let's make sure that those are lined up and the same. We push those images up to Docker Hub. And then now we're going to be checking out our configuration code. So we can check out code from another repo inside of our GitHub action. So I'm going to check it out from my config code repo. And then when I get that, I give it a path. I give it config repo path there in the middle, where that way I can identify that the code that I'm checking out from that repository. Inside of config repo, it's a little big because I want to make it big so you can see it. So I'm going to scroll to the right here just for a second. I'm going to reference config repo. And inside the config directory, I have my Kubernetes manifest. My K8s manifest that we showed you before with my couple of deployments, my couple of services, and my ingress. I want to be able to perform a find and replace sort of action on this file. So I'm going to look for my placeholder values, the things in all caps. And then I'm going to stick values for my SHA in there, for my image labels. And then for my front-end URL, vars dot all caps. These are values that or variables that you save inside of your GitHub repository that you have there. And in this case, we're using the sed command. It's a command line command that allows you to do this type of find and replace inside of a file. In this situation, you could also use a templating engine, something like Kustomize or Jinja. Depends on what you want to use. Again, it goes back to that conversation about there are many different tools for each step, and these are just the tools I'm using today. Next in our GitHub action, we're going to be installing the Helm charts that we need. Or in this particular case, we need a Helm chart. We need the ngrok operator so that we can use that to provide our ingress. The reason why we went with ngrok is because ngrok allows you to set up your URL to pass to the ngrok service that's referring to that URL without having to know anything about that cluster aside from the fact that it's tied to it using this ngrok operator. So you don't need to know any IP addresses of services or anything like that. So that's why we went with ngrok today. Then we apply our K8s file. And with that cluster running, we're going to build our test container, and then we're going to run it. We're going to pass in that front-end test URL that we have. We set that front-end test URL inside of you saw that inside of our test code, but we also gave it inside of our GitHub repository as well. GitHub allows you to store variables and secrets and things, and those are the values that you're seeing with the vars inside of this file. All right. In fact, we'll go to that point in our GitHub action. And I recorded going through this. What's the nice thing about video is that we can step through it. I can pause it. I can skip through things. Bad part is I can't really change resolution, so sorry about that. But I'll get this going here. And essentially what I'm doing is I see a change that I want to make in my website. I want to change the title because I'm realizing this is not a burger joints list for all burger joints in the world, just in Seattle, Washington, which is where I'm from. And so I make the change to say burger places of Seattle. And then I'm going to be pushing that code up. So I'll commit that. And we can assume we know what's going on there. So I'm going to skip through that a little bit. And it's going to push that code up to GitHub for us. And now I open a pull request. That pull request then launches into our GitHub action. What's nice about watching this, and I'm not going to make us watch the whole thing, but it's going to start building and installing all of our dependencies. We saw at the beginning there, before it started spinning away, that it was grabbing K3s so that we could use that. And now it's going to build the Docker images of our back end and our front end. We're going to skip across those, because that takes time. Again, it goes back to that whole slide. Remember with the weightlifter, it does take time. And then now, we'll skip here to our test. And then right here, our test ran. Whoop. It's always harder doing something in front of people. There we go. we're going to see just 3 tests pass, all 4 tests pass, I promise. I just don't want to spend time trying to scrub to it. But we see how our tests pass, and then it can move on to the next steps in our GitHub action. If our tests don't pass, frameworks like Cypress can provide resources like giving you a screenshot of what things look like. And in this, for an example here, I can come out to my test code and say, oh, what does it look like when it failed? And I say, oh, here's a screenshot when it couldn't load that very first test. It said, this is what I saw. That's what Cypress is saying. So you can have that as a resource while you're running your tests. So our tests pass, and we skip into the next portion of our GitHub action, which is going to be doing a deploy. And this is where I want to talk a little bit more about our GitOps principles. GitOps is a philosophy of essentially saying our infrastructure is being defined as code. We should use Git as that source of truth. Git is where we should have everything, all our configuration stored. You don't make changes by hand. You make changes by committing to our Git repository and then having a list. That way, now you have a history of every change that you've made. You know exactly what changed, who changed it, and when they changed it. It's all happening inside of Git. But then also, you have these processes like the one we just saw. The GitHub action, which is happening with our Git process, where we're pushing the code up and we can start running automation on that code so that when we're pushing our configuration changes, we can test to make sure our configuration actually works and our application actually works. Git acts as our source of truth. And then what I'm going to talk about next is an idea, again, in the GitOps community, where they talk about the rendered manifest pattern. This is a pattern where you have your manifests, our Kate's config files that are actually going to be fully rendered with the values that we want to use to deploy that are sitting and waiting inside of a repository so that our CD process can pick those up. It's not going to, that CD process is not going to be finding a template and then swapping out values. We're actually going to have the rendered version of that manifest. So in our case here, during our GitHub action, below the tests, after the tests pass, we had the GitHub action commit our changes back to the config repository. But instead of putting it in main, it actually created, there are branches for testing, for render test and render prod. And in this case, we made those branches that are never going to merge back to main. They're going to be their own spots that our CD process will watch for. Our main branch will keep having that template, the templated values, so that we have the placeholder values inside there. Inside of here, inside of the render branches, we have our fully rendered configurations. The nice thing about this, I'll let this run while I talk. The nice thing about this is you'll have a full history, again, of the configurations of your application, not only for production, but also for test. For test, those are the things that just ran inside of the GitHub action. But then now you have that test. If you wanted to run additional tests while your application was out in the world, you can also do that, something called smoke screening, to make sure that you can find things before your users find them. You can find them first. So in this case here, we see that rendered manifest where we have the image labels. We have the URL value here in our test branch. And then we also have yay for videos. All right, right here. We're not going to do this today, are we? So you also saw that we had image labels, and they had the SHAs that were from the git commit and inside of our manifest there. So we'll skip on to our next step. Now that we have rendered manifests and they're sitting in the branches, ready to be rendered, ready to be deployed, we're going to introduce our last tool of the day, and that is Argo CD. Argo CD is going to be watching our specific branches and saying, all right, I'm going to watch the specific branch, and when there's changes to that branch, I'm going to deploy it. In our case here, we'll look at the render prod branch. I'll have this video run. You'll want to watch. You see those turquoise sort of boxes down in the lower right-hand corner? That's where you want to see the changes when something syncs. That's going to be processing our changes to our cluster before we push out to production. We check, make sure that our ingress is set, our deployments are set. And then we can go and see that our production site, the change has been made. So I made that change to the title, and I'm confident that I made changes that didn't adversely affect my system, and then also did exactly what I wanted it to do. Now, to the keen eye, you'll notice that this list is 0 before they started filling out the form here, and the previous one was not. Well, that's because this application is running with local storage. So in real life, you'll want to have a persistent volume, some persistent storage, so that you don't lose data every time you make a new image. So you might be thinking, Scott, that's nice. My application's a little bit bigger than 2 deployments or 2 services. I have a lot more CRDs in my application. This is going to take a lot longer to build and a lot longer to test. And you're not wrong. I actually recently learned of a new project, not new, I'm new to the project, vCluster. vCluster is a Kubernetes distribution that allows you to have a cluster inside of a cluster. So in a sense, you can have an ephemeral, temporary Kubernetes cluster that's running inside of a host cluster. Now, how would this help with testing? Imagine this for a second. You have your cluster that's sitting on your cloud or in bare metal, sitting in the world, and it's running a vCluster of your production environment, and that's fine. But then it has all the CRDs set up and installed inside of the host cluster, and you want to test with those same CRDs, the same versions of those CRDs. With vCluster, you're able to spin up a new vCluster, use all those same CRDs, test the thing out, and then spin it down. You can do all that actually from a GitHub action. I joined the team last week, so I don't have anything ready to show you. But what I do have is I have a link to some resources that my colleague Siam has made that is also available that I'll show you here in a QR code in just a second. You can see how to do that. In fact, I do believe it is that QR code. I created a channel on our community Slack workspace. It's for general discussion of testing, but also has a link to the slides that I saw. It's actually an extended version of the slides because I had to chop out a whole bunch of slides. And then also has links to the repositories, links to Siam's article on how to how to spin up an ephemeral environment in a pull request, similar to what I just did, but with vCluster instead. I'm Scott McAllister, a developer advocate who recently joined Loft Labs, the makers of vCluster. I want to thank you all so much for coming to my talk today and hope that you have a wonderful rest of your day and safe travels after the next talk.